Dr. Laura Tuohilampi. She is a researcher in researching in University of South Wales, Australia, and she has researched her whole life about mathematics and how we study and take mathematics. Her life goal is making mathematics interesting and enjoyable for everyone. She is an expert in everything, but I am interviewing her as an expert of mathematics and education. So this was, and she is also my very good friend. So this was my introduction. Laura, can you please introduce yourself in your words and tell us who you are and what you do?
Thank you, Rohan, so much for your amazing introduction. You're also the best host ever. So thank you for inviting me in your YouTube podcast. I've been doing research of mathematics learning and teaching basically my whole life. As you said, I started as a mathematics teacher, and even as a small child, I was interested in science and mathematics, and also in the dilemma of why is it so negatively perceived, as at the same time while people hate mathematics and the experience that they get from schools, they still enjoy brain challenges. We all enjoy challenging our thinking and our brains, and even like really traditional riddles. So it's not something that anybody hates, but for some reason the school experience that we give is really unhuman.
I completely agree that experience is completely inhuman. So let's come to our first question. So my first question is that suppose, like, it's a very real life example and most of the people experience that. Suppose there is a person who never liked mathematics because of some reason, because of bad teachers or not getting proper guidance, and somehow he enters a course that is very math extensive, for example engineering or economics, something like that, and now he has to study mathematics, he or she has to study mathematics, but that person doesn't know where to start because his or her basics are not clear. She doesn't know where to start. So what can they do? Or there is an adult maybe who is like 35 years old, and he never liked mathematics. Now he wants to start understand mathematics, maybe to teach his children or just in general to feel good, because being a master of mathematics feels good. So what should be their approach? Because they have to start from primary or secondary level and then reach higher level of mathematics. So what should be their approach?
Well, I would start by congratulating myself, because the most important step has been taken at that stage already. That is facing mathematics in your previous experiences, and I think that's the most difficult step to take. So for many people that have really negative experiences, they just ignore mathematics and that for the rest of their lives. So it's a really big step to actually face that again and start over. So after tapping yourself in the shoulder, I think the second step that is really important is to find some joy in that learning. So maybe you can't really have much control over the teacher or whatever, like maybe the curriculum that you have to go through, but you can always first of all understand that mathematics isn't that difficult. Like, of course, if you are able, like, if you want to do like a PhD in pure mathematics or something like that, that's going to be difficult, but the basics are not too difficult. We can all learn stuff, so it's not something that we have to be born with. It's more about some hard work. Sometimes it's a little bit boring, a little bit tedious and so on, but some of the journey is also a lot of fun. So first of all, acknowledge that you are able to learn mathematics. And if you do need to study in a really boring program, or maybe your teacher is really, distant or difficult, or presents the content in a complicated way, so you can always use YouTube videos, and there are like lots of people that are making a big effort in making mathematics content really approachable.
Well, the last point that you added, using YouTube, I would like to just add on to the point that YouTube University is the most underrated university in the world, because on YouTube you do not have to just when you are in college, you do not have a choice, but on YouTube you have choice. You have thousands of video, from that you can just select which ones you like. So that was a great example. So if you want to start, then find a YouTube channel. I saw a professor from Laura's University. He has an amazing maths channel. So, and there are many more. Like MIT has mathematics videos and all that. So you can just go to YouTube and just start somewhere, start facing it, and then you will become better. So the next question is exactly opposite of the first one. Suppose there is a person who loved mathematics his whole life. He is good at mathematics, and then he obviously entered a math extensive course, maybe graduation in pure mathematics or maybe engineering or something like that. And then because of some reason, he stopped enjoying mathematics or he started finding it very difficult. So what should be their approach? Because this is just the opposite case.
Well, first of all, that's a more like that's a rarer case. So
I know many people like that. I know many people like that.
Maybe you're right. Maybe it's just something that I haven't been dealing with that much. But maybe I just use myself as an example. Like sometimes I face problems. Like I've never had a problem with mathematics, even the boring stuff or the one that really requires a lot of like muscles and stuff like that. But sometimes I face challenges that are just super difficult, and I just don't have the tools to solve those problems. So like basically like maybe starting from what's the problem there, like are they losing their interest, or is it like just a challenging problem? Because you can always use collaboration. You don't have to solve all your problems by yourself. If it's just about like losing your enjoyment with mathematics, maybe you just have to do something else in your life. Like I think it's more, but I don't want to say that as a more complicated problem, but it might have like different sort of aspects. So I would start by sort of like addressing what the problem really is. Is it about the difficulty of the content or something else?
Okay, so what I take from this explanation is, first of all, finding the cause of problem is very important. That what is causing the loss of interest? Is it the problems that are difficulty? And second point that I would like to highlight in Laura's explanation is collaboration. That asking for help will always help you. You can ask from help from a professor. If you do not like your professor, then maybe some other professors, some teacher assistant, or maybe some senior, or maybe your batchmate, because batchmates are the best teachers. So ask for help. That is what I would like to highlight in your explanation. So my third question is for teachers or some parents who teach their kids. So few days ago, I was watching listening to a podcast by Dr. Andrew Huberman, who is a neuroscientist, and he was explaining that the brain of a child about 5 to 7 years old is very plastic. And what I mean by that is that one or two experiences are enough to change that brain completely and permanently. So if you, by any chance, your actions say to the child that you are not good at mathematics, the child might take it very seriously, and he might start hating mathematics for his life, and he will start believing that he's not good at mathematics, and he will keep believing it for his life. So when we are dealing with that age group, we have to be very careful, because those minds are very sensitive and can change just by one experience. So what are your advice for primary teachers or parents who teach their kids in the age group of 5 to 12?
Well, you kind of explained or proposed one of those solutions already, to not even start doing that damage or making that damage. But if that is done already, there is, like you say, that just one experience might change your beliefs into something really negative about yourself. But that only also works the other way around, because what we also know about human brain is that we do hold beliefs about, like, let's say, ourselves. And it's really difficult for me. Let's say I've always thought that I am bad at mathematics and I'm incapable of learning mathematics. So it might be really, really difficult for me to change that belief about myself. But I can always believe something that is confronting that belief. I just need to have an explanation for that. So we are talking, it's called like belief systems. We can hold beliefs that are totally confronting. Let's say I'm bad at maths, and I'm also like good at maths. I just need to have an explanation, like I can learn mathematics with this teacher, or I was bad at maths when I was a child, but as an adult, I'm able to learn mathematics. So it's possible to hold different beliefs about yourself. It's probably easier than changing that original belief. You just have to give yourself an explanation. It's the same way when let's say I moved from Finland to Australia, and it was really, I kind of used that to change lots of my habits, because I was able to give myself an explanation, like, now that I live in Australia, I can do this and this and this. So I was sort of like tricking my brains to believe that I'm a different person here. So that way I can change, like I can create new beliefs about myself.
Okay. So the highlight from that explanation was that maybe you are not able to change that belief. So try to find alternate beliefs that can help you achieve your goal. Okay. Wonderful. And again, I was reading a paper about psychology and neuroscience, some papers about, and there was a very funny thing about that. And that thing was that human mind has evolved to uh, recognize patterns and think logically and do calculations. So that is the only basic difference between the mind of a gorilla and the mind of a human, that the human mind can do calculations and recognizing patterns much better than a gorilla brain. So if you believe that you are bad at mathematics or you cannot do mathematics, then you are believing that you are a gorilla. So what is your take on that?
Well, I'd like to add something to that intriguing information. I also just learned, it's a couple of weeks ago, that even though lots of I'm not sure about the species, but like apes, or I don't know, maybe gorillas, they are able to sign language, so like communicate
Mhm.
in general. But none of the other species than humans have ever posed a question. And I think that's a really fascinating detail about human beings. And I think that's the core of how we are as human beings. And it's curiosity. We are able to imagine things and visualize things that don't exist and ask questions. So I think that, like in the core of learning like anything new, that also includes mathematics, is that curiosity. Like, can I even see something? Can I like identify patterns? Do I see a question here? Is there a challenge? Like, what can I ask here? Not just about learning or like figuring out the answers, but I think the beauty of the learning process and believing yourself as someone that is capable in learning mathematics is to appreciate your ability to pose questions.
That explanation reminds me of the great Richard Feynman. I know you are his fan too, and he says that science is not about finding answers. Science is about finding questions.
Mm-hmm.
That's what learning is.
Mm-hmm.
And okay, I know you have limited time, so I'll pose my just last question. And the last question is: most of the teachers in this school and colleges are experts in their fields, for example, history or mathematics or something like that. But very less percentage of teachers are trained in psychology. They have no knowledge of psychology and they do no effort to read some psychology books or put any effort in learning how the brain works or how that age group they are teaching, how they perceive things. So do you think that psychology education should be made compulsory for teachers of all subjects? Because if they cannot understand their audience, they cannot deliver their content properly.
I think it's included in most teacher education programs, but only for like maybe like 1 or 2 courses or something. But even in that content, there could be a little more about the
Yeah.
affective aspects of learning, not just because like let's say in mathematics teacher programs, which I am like responsible of, we talk a lot about things like how do children develop like conceptual understanding of fractions, like how is the learning process cognitively happening, and that's like the psychology of that learning process. But we talk less about identities and emotions and like the values of that learning process and appreciating you struggling with that content and all that stuff. So yeah, I'm definitely an advocate in sort of like pushing the education programs to have more of those aspects as well.
Okay. So the emotion is the key to learning. When we associate some emotion to a memory, that memory becomes permanent in our brain. In our childhood, we remember the instances which had a very strong emotion associated to it. So same is the thing with learning. If we associate emotions, we will be able to learn better and easier. The last thing is, are there some books that you would like to recommend? Because like I would like to recommend a book first, Richard Feynman's books. Like he is just wonderful. So any other book that you would like to recommend?
Oh, there are so many interesting books. Like you mentioned Richard Feynman. Like I've been always really interested in those like true scientists and their lives. And there was a book of the famous equation. E is say in second power, like all that. So, but there are also really interesting books of mathematics and mathematics learning as such. And I had to recommend my own book that is coming out like early next
Uh,
year.
that is that is my job. That is my job. I'll do that. I'm the host. I'll do that. I saved the
Yeah,
best part
because
for the end.
that's on my plate, and that's like the something that I'm really proud of, and I'm trying to put all the expertise, and I've also included the work of so many other researchers and educators in the field. So it's going to be like a summary of what we have achieved so far.
Okay, so audience, so viewers, Laura's book is coming very soon. It's called Math Hunger. Laura is also the founder of a company called Math Hunger, and this also shows that she is a very successful businesswoman. And I will just post the link to her Instagram page and her website, Math Hunger website, in the description below, and you can just check her work. And she is also very fit, fitness enthusiast, so you will just love her Instagram profile. I'll post all her details in the description below. And she also provide courses and mathematical advice and some consultancy types of advices to teachers and schools. So if you are a teacher, administrator, school administrator, and you require that, you can just contact them. So this was today's podcast. I hope that you learned something. Thank you so much for watching.
Thank you, Rohan. Thank you, everybody. See you.